Okay, I see that we already have quite many participants, so welcome to you all. It gives me really great pleasure to welcome you all to the event number 17 of the networking channel. It has been a year now that we started in March 2021, and we are really delighted to see that the audience and the participation is always very strong. So today we're very happy to host a program dealing with a very, of course, hotly debated topic, 6G vision and the perspective for transatlantic cooperation. I believe we can extend this to other type of cooperation as long as it is mutually beneficial. And I will then thank Alain for very gently organizing this event, and of course the panelists, Douglas, David, and Mikko for joining. And Alain, the floor is yours.
Thank you very much, Serge. Good morning, good afternoon, good evening, wherever you are. My name is Alain Mourad. I'm a senior director at InterDigital and the lead of the Horizon 2020 Empower Roadmap Working Group. I'll share my screen. You should be able to see my screen now. Put it in slideshow mode. Okay. That should be coming up on the screen. And with me today, I have a stellar of three panelists. David Boswarthick, Director of New Technologies at ETSI. Mikko Uusitalo, Head of Radio Systems Research at Nokia Bell Labs in Finland. And my colleague, Douglas Castor, Senior Director at InterDigital and the Vice Chair of ATIS NGA Roadmap Working Group. I'll kick off the panel with an introduction. As of today, the wireless research and innovation community has been actively pursuing technology development on two fronts. The first front is the advancement of 5G, following a backward compatible agenda. And the second front is a more disruptive front, looking at technologies that's promising for 6G with a time horizon of 2030 for such a system. And the expectation is that come 2025, there is going to be an inflection point where the progressive advancement of 5G in a backward compatible manner would not be enough to meet the requirements of the services envisioned for the time horizon 2030-2040. So this is when we expect to see a need to start a new generation, which is dubbed as 6G today. So all the key research and innovation stakeholders in the development of 6G have been quite busy. So I just name key stakeholders around the vision and the requirements, like, for example, the ITUR, IMT 2030 activity in the NGMN, the Operators Alliance, the GSMA, and multiple vertical forums like 5G Asia, EA, and the likes. But also the research and innovation community has been quite busy in exploring the technology landscape, aligning with the vision and requirements coming from those stakeholders I just mentioned earlier. And maybe to name a few on these R&I kind of stakeholders. So we have, for example, in Europe, the Horizon Europe SNS 6G, the Horizon 2020, HEXA-X 6G flagship project, represented today with Mikko, who's the lead of that project. In the USA, we have the ATIS NGA, Next Generation Alliance, represented today by my colleague Doug Castor. In the UK, we have a similar kind of activity around 6G. In Asia, in China, Japan, Korea, multiple 6G fora. So all heavily incubating and exploring the technology landscape for 6G. And the standard bodies, they are not sitting idle, so they are very much watching the 6G landscape and planning their pipeline of next specifications to support the development of 6G. And here we have, for example, David representing ETSI, the European Telecom Standard Institute. Other standard bodies are quite active in developing that pipeline, like in IEEE, IETF, the 3GPP, and ITUT, amongst others. So in the Empower project, so this is a project that we started back in 2018 between Europe and the United States. It's funded by the European Commission. And the objective of the road mapping working group in Empower has been to develop a roadmap that covers the short-term, mid-term, and long-term development of 5G. So essentially, that covers the 5G advanced by 2025, but also 6G by 2030, if I put this simply. And to develop that roadmap, we followed a classical approach or a conventional approach by trying to address the envisioned services, the requirements or the capabilities to meet, to support these services, and then what kind of technology trends or technology enablers would allow us to meet these capabilities, right? So this is pretty much the standard way of looking at the road mapping. So here on this slide, I show 4 categories of services or use cases. So we developed multiple use cases, and then we classified or clustered these into 4 classes. The multisensory extreme reality and haptics, connected industries and automation, autonomous vehicles and swarm systems, extreme coverage and reaching the last billion. And we try to address actually the impact of these classes of use cases on the 5G KPIs by demonstrating or representing a heat map that you see here on the screen. And just to show actually how well aligned the Empower project has been into envisioning the services. So I put here on the slide actually what is currently the status in terms of services envisioned for 6G into the ITUR IMT 2030 draft. So this is still a draft. It's not actually fully released yet, but you appreciate actually quite a direct mapping of the 4 classes of use cases we had in Empower to what is being now planned or coming up to the ITUR IMT 2030. As I said, so following the services envisioned, we developed the target capabilities. So first on the wireless subsystem side, so showing what is the current state in IMT 2020 and the direction of travel all the way up to IMT 2030. Just to pick one example, so say spectrum today, IMT 2020, we go up to 100 gigahertz. If you, the forecast to 2030 is that maybe we go up to 300 gigahertz. And all these are not, if you like, just a matter of a random guess, but these are actually really informed predictions based on the services and the requirements that we developed in the project. And we did not actually stop at the wireless subsystem or the radio interface or the radio system, if I may call it this way. We also did the similar exercise on the network capabilities. So there is no reference for the network capabilities like there is one for the IMT 2030 and the IMT 2020. So here we just followed multiple fora on these soft features or network capabilities. So same story here, we developed the direction of travel. For example, if I take automation as a capability, so today Network 2020, this is a bit like a human-operated networks, and the vision in terms of that capability developing all the way up to 2030 is that the network is going to be self-operating with human operators only required to validate certain decisions by the network. Right? And following on these capabilities, we developed timelines for technology trends on the wireless side, so short-term, mid-term, and long-term. And likewise on the network side, short-term, mid-term, and long-term to support the capabilities that we developed in the project. So with this, I'll stop here. So I just wanted to set the scene here and what we did in the Empower project. And now I will turn it over to you, David, to take us with the ETSI perspective on 6G. So you should be able to share your screen right now.
Hello. Can you see my slides?
Yes, very well. Yeah.
Excellent. Okay. Good morning, good afternoon, good evening, everybody. My name is David Boswarthick. I work for ETSI. Hopefully, most of you know who ETSI or what ETSI is. We're the European standards body based in France, working in the domain of ICT technologies. So we have about 930 members from all dimensions, from vendors to operators, network integrators, system integrators, testing houses, governments, European Commission. Everybody is involved in this organization. And our prime purpose is to make ICT standards, ranging from different sorts of technologies. Out of those 930 members, I just wanted to call out, we have about 140 members who are research, public and private, or universities. So we have a very large amount of researchers inside our organization. What we try to do, so I've shortened this presentation, there's a longer version available. What we try to do is to accelerate the output of research projects into early standards. So we recognize that there is a lot of a lot of research activities out there happening in private labs, public labs, universities, in individual regions. And what we're trying to do is when that research is ready to be moved to standardizations, we tend to talk with those communities to help them move forward. A lot of researchers don't actually know what the purpose of standardization is, and it's not always considered in some projects. So what we're trying to do is communicate with researchers and academics, which is good because I think there's quite a few on this channel today, and explain to them how by moving their really, really innovative research projects into standardization, they can get greater outreach, greater community onboarding, and then actually get those solutions into network standards out there. So we've created this thing in ETSI called ISGs, Industry Specification Groups. And these are really small standards groups, which are very quick to set up, very easy to run, light and easy, as opposed to a full-fledged partnership project or technical committee, where researchers and industry can come and look at things such as millimeter wave transmission, network function virtualization or virtualized networks, edge computing, artificial intelligence, AR, VR, XR. So all these very interesting technologies, we've actually set up ISGs, small standards groups for them, and we brought communities together so they can start producing early specifications. And the interesting element is this is open to both ETSI members and ETSI non-members who can come and participate as well. So it's a very open process to get into early standards very quickly. This worked very well for 5G. So you may know I'm in Mobile World Congress this week in Barcelona, and everybody is waving their flags about 5G Advanced, which is the evolution of 5G. And this worked very well. We had a number of ISGs looking at building block technologies for 5G. So you can look at NFV for virtualization, OSM, which is an open source MANO, so looking at a very specific area of NFV, but with open source standardization techniques, millimeter wave, MEC, ZSM, ENI, looking at network virtualization and autonomous networking, zero-touch networking, SAI, which is looking at how AI can be used to secure networks, and also how AI can be used to attack networks, so you actually need to defend against it, having secure AI. And also the evolution of IPv6 and IP, non-IP evolutions at the lower levels, because possibly as we move towards 6G, these technologies will need a higher performing lower layer. We've started thinking what may happen in 6G. I think it's really important to say that nobody really knows what 6G will be. There's a lot of visions out there. We know some of the use cases. We know a few of the eventual candidate technologies, let's say terahertz, but nobody really knows what it is. And also some of these technologies may pop up in 5G Advanced, 5G Evolved, because these two technologies will coexist for a number of years. But by reading various vision documents from HEXA-X, from the ITU, from others, we've come up with a list of things which may be interesting. And it's interesting to see that this actually maps on very nicely to the presentation that Alain gave with the work that's been done in the Empower project. So this is fantastic. So we can see things such as sub-terahertz and full terahertz, reconfigurable intelligent surfaces. The topic of energy sustainability, or just sustainability, not just energy sustainability, is very, very important. In Barcelona, everybody is talking about how they can reduce the energy consumption of the network, which is one of the biggest costs for the operator and also very important for the planet. Non-terrestrial networks, which is already a part of 3GPP release, 3GPP, but 5G, but how to further extend space-to-space communication, space-to-networks communication beyond just backhaul. So that's a very interesting area. And also having communication networks which can actually sense the environment around them, either be that via radio or even over fiber optics. There's certain temperature applications where fiber optics can sense what is around them. So having a communication network that can actually sense things is very interesting. And then as we move towards cloud, edge, and also the supercomputer, let's say, as computers get more and more powerful and the architectures of computers change, it's how with the compute fabric and the communications fabric converge. So we've come up with something called communications compute convergence, which is just an acronym invented. And then finally, as you move way up the spectrum towards visible light or infrared, is the whole domain of optical wireless communication. So these are potential 6G building blocks, which could fit very nicely into early standardization ISGs. So to get here, we did something, I'll go quite quickly, we did something called the technology radar, which is very similar to the work done by InPower. And here we looked at the most relevant vision documents and came out with the corresponding technology trends. We published this last year and we'll be revising it this year with the latest evolution, because obviously the future evolves very quickly. Just to give you some of the high level points. So in the technology radar, there are 10 really high level areas. The evolution of 5G, so taking you up really to the end of 5G advanced and then beyond into 6G. The presence of artificial intelligence at various parts of the network, and then how can you connect that artificial intelligence, machine learning together, and also securing it. The fully autonomous network, self-healing network, self-synthesizing network. Everything relating to security, cybersecurity, trust, privacy, and making sure that AI doesn't run away with the system. Distributed ledger or carrier-grade blockchain, which is a very important tool. Dynamic data, otherwise known as big data, data analytics, how to manage dynamic data, and also how to name and verify dynamic data. Everything related to augmented reality, virtual reality, mixed reality, which takes us towards the all-famed metaverse. IoT and the extension thereof, so Internet of Things, Internet of Everything, and then moving towards the Internet of Senses and the Internet of Skills. Quantum, which is a vast domain of research, looking at quantum key distribution, which is one element used for end-to-end security, but also quantum safe computing and quantum secure. This we actually have standardization work in ETSI today, but as you move forward, you can look to quantum information technologies. You can look at quantum internet, quantum metrology, so actually having a clock used by quantum technologies. And then autonomous system, which is another way of looking at robotics, drones, autonomous vehicles. So that's in the radar today. As we look forward, and this is by feeding out with our partners and saying, what do you think should be on the radar soon? We see the whole domain of photonics, terabit ponds, optical networks, photonics for space communications, photodiodes for terahertz, linking this into optical wireless communications, photonic sensing, very interesting area. And what we tend to do in the radar is, look, this is the technology, this is the standards that is happening. What do we need to do in between? As I mentioned, sub-terahertz and terahertz, reflective intelligent surfaces, which I'll come to very quickly. I don't have too much time, I would think. Optical wireless communications, non-terrestrial networks, so from all the way from the sky with drones and HAPS up to lower orbit satellites and full orbit satellites. The evolution of edge, and then when you bring AI into the edge and making edge native for 6G networks. And then the integrated sensing and communications network, as I mentioned earlier, will be a very interesting area, and bringing into this high performance compute. The software virtualization of the core network, of the radio network, and the end-to-end network. And as mentioned earlier, something which is very important, everybody is talking about it, is sustainability and energy efficiency, bringing energy out of the network and put it into the device. Look into the future, there's a number of use cases which are often used in 6G vision documents, so digital twins, Internet of Everything, Internet of Skills, haptic internet, the ability to touch and feel, holographic communications, the metaverse, let's say full extended augmented reality. But also something we're looking at is what will the next generation of device be? Will it be a smartphone? Will it be a connected car? Will it be an AR, VR headset? Will it be an implant into the brain? So the whole area of what is the next technology and what standards will be required. Let me just go quickly. The important thing we're trying to show is when you have funding and research roadmaps on the left, this ends up with research and corporate projects. And we want to make sure that all of that really good academic research work, which may come through European projects, which may come from national projects, actually, if they need to, and they're mature enough, can come through the standards channel and get very quickly into the big global standards bodies where they need to be, such as 3GPP for 6G. One example of this is ISG-RIS, or Reconfigurable Intelligence Services. So this is basically optimizing radio waves by bouncing them in effect intelligently off smart surfaces. And what we saw here, we had a number of European projects, UK projects, which were looking to doing early standards. So what we did, we opened up an ISG late last year, October, September, and they're already from a research base. And I think there were 7 researchers, Alain could probably correct me, research institutes, and then in industrial members as well, moving that forward to produce some early specifications. It's important really that we don't talk too publicly in things like Mobile World Congress about 6G, because everybody is working on deploying and developing 5G. So in ETSI, we only talk about research and pre-standards and candidate technologies. What we're seeing now is people are sharing their research timescales, their standards timescales, and their visions for the future. So this is why events like this are really good. We can actually see what everybody is thinking when they think 6G will be out there and come to some point of convergence. And it's important to remember, as 2G, 3G, 4G, 5G coexist, although some networks are being turned off, 2G and 3G, 5G advanced and 6G will also coexist. So what elements will be moved between them? Quick conclusion, it's very good that we share technology radars and everybody has a different technology radar and get feedback from each other. 6G is expected to emerge on the market around 2030. Some people are saying 2028. So it's good to keep that alignment of where we think we're going. And also ETSI has a role to play in bringing these, in this context, European research projects into pre-standards and then making sure they're accelerated very quickly into 3GPP. So I hope I didn't go over on time. With that, I will end. Thank you very much.
Yep, thank you very much, David. Still on time. It's absolutely perfect. So with this, I'm going to be handing it over to Mikko. So Mikko, if you can please share your screen and take the floor.
Yeah, thanks, Alain. So let me also share my screen and the slides that hopefully now are well visible. So I'm Mikko Uusitalo, as said, coming from Nokia Bell Labs Finland, and also then leading the HEXA-X project, and here in mainly in that capacity. So HEXA-X is the European level 6G flagship project funded by European Commission. And let me tell you a bit more about the project. So as said, we are the only European level flagship 6G research project, and we are developing the foundation, contributing to industry consensus leading to 6G. So focusing at this phase on structuring, framing, developing technology for connectivity needs in this 2030 timeframe. We have an excellent consortium, so Nokia overall leader, Ericsson technical manager. We have R&D intensive operators, high quality industry, academia, and SMEs in the consortium. The time frame you already saw from David, but let me also share some thoughts here. So now, as said, we are at this phase of structuring, framing, openly coming together and understanding the needs for new generation and the vision, what kind of technologies could play a role here, and then moving moving forward in this relatively long cycle that historically has been for the generations around 10 years. So next phase would be to move then more towards systemization, then halfway through the decade to standardization, and then towards the end of the decade towards commercialization. So then about the vision of HEXA-X on 6G. So we see that the 6G is needed to bring together three worlds: human world, physical world, and digital world. So human world is of course part of the physical world, and we need to be in balance with the physical world. But as the technology is designed primarily for humans, so they are then highlighted here. So it's technology designed for us. And we need to be in control of the physical world with efficient human-machine interfaces, with also then needing the real-time efficient connectivity between the human and physical worlds. Also, we need efficient connectivity between the human and digital world in order to build models of humans and collect information on parameters from our body, and with the help of such models then for example predict any potential problems related to our health, like detecting approaching heart attack before it happens and proactively call for help. Then we also need efficient connection between the digital and physical world. Also here then to build models of the physical world, then being then able to operate the physical world. Then we have then listed recognized set of use cases that we expect to be needed for kind of that they need 6G. And actually, as fresh as yesterday, we published our most recent deliverable available from our website, telling more about the use cases and also moving forward from them, that then if you have these use cases, what do we then really need for these use cases? Sustainability was already highlighted, so very central for any future activities. 6G needs to be sustainable in many ways: energy, material efficiency, carbon emissions, so on. And also we need to see that how could 6G be used in other sectors of society to make them more sustainable. Moving to the use case family, massive twinning. So we already have digital twins, and taking this to the next scale, modeling large industrial complexes, entire cities, as said, to be better able to design, operate plant operations there, and also here detect problems before they occur and proactively react on those. Then use case family telepresence is about a human or set of humans interacting with other humans, or interacting with other machines, or interacting with the digital world with some objects that don't exist in physical form anywhere, using any available senses, any senses that are needed, and then of course independent of location. And this can be applied in various contexts. Robots to cobots, about augmenting humans, being better able to predict what is needed, and so on. You can find more information on these from our document published on our site yesterday. Then we also have announced already 1 year ago central research challenges for 6G. And for all of those research challenges, you can find new deliverables telling more that what is really needed for those and what kind of technologies are relevant and what do we expect to be getting from the current technologies and so what is needed, as well as we have initial material on some technical enablers. So on these research challenges, already talked about sustainability. Network of networks refers to the challenge of having networks at various hierarchical levels. Connecting intelligence is central with this machine learning based technologies can now be taken into a board with 6G right from the very beginning of the design of the generation. Trustworthiness, very central for the success of 6G. Extreme experience, taking all the previous generation central key performance indicators to the next level, as well as then global service coverage, already pointed out also by David, lowering the threshold for using these services, as well as then reaching remote locations. Then one central technology to cope with the ever-increasing amount of wireless traffic is to look at higher frequencies for the radio technology. Immediately then have to also add that the lower frequencies are also very central to keep in mind for 6G, but the kind of most novelty is in the higher frequencies that can be used for short-range wireless links to any directions, for longer range fixed direction links, and then sensing. So with the same hardware used only for communication, on top of the communication with the same hardware, one can get additional information on the environment. So that's the new feature with 6G sensing. Then some more data on these requirements and approach for the radio. First wave 6G, looking at the data rates 100 gigabits per second and longer term 1 terabits per second. And when moving to the ever higher requirements, need to go to look at the higher frequencies, meaning then also shorter ranges. As said, the AI machine learning very central. It is already widely used in high layers of the network in 4G, 5G, but then it of course needs to be looked with the fresh eye for 6G at the high layers, but then also more novel in the lower layers of the network. Sustainability, also in the new deliverable we published yesterday, novel information on the sustainability targets and the key performance indicators and methods to move towards fulfilling these needs. On the spectrum, highlighting the need to take a fresh look at 6 to 24 gigahertz that was excluded at early stages from the 5G, as well as then look at the earlier traditional frequencies and higher frequencies. So as conclusion, 6G will be much broader than radio access technology. It's a flexible platform providing connectivity, data, compute, intelligence, and you can find new results in all of these areas already from our website, and also some overview document from end of November last year at the IEEE Access. Thank you.
Thank you very much, Mikko, for the nice presentation. So now we'll hand over to you, Doug, to give us the ATIS NGA perspective.
Okay, thank you, everyone. Let me just put the slides up on the screen. Okay, you're able to see the slides? Is that
absolutely, yeah, that's good.
All right, yeah. So yeah, thank you, Alain, for that introduction. I'm very pleased to be here today and to be joined by some of the esteemed colleagues in this journey to 6G. You know, as I mentioned, I'm one of the vice chairs of the Next G Alliance working group, the roadmap working group, and I work alongside some of the names you see here. And for those of you that are not familiar with ATIS and Next Alliance, Next Alliance is a group under ATIS, and ATIS is, of course, one of the 7 partners of 3GPP. So Next Alliance was formed by ATIS in late 2020 and was followed by about a 6-month period of membership building and working group formation. So we started working on a roadmap report in June of 2021 and had the first report drafted by the end of the year. This can be found on the Next Alliance website, and the cover page is shown here on the left-hand side of the slide. And really, this is a report about the foundation of the North American 6G vision and leadership. North America has not before had a group of this magnitude that has that can provide a common voice over the 6G vision and execution. And it doesn't have projects like Horizon set of projects in Europe or specific funding efforts for 6G like we see in some Asian countries. So what Next Alliance is looking to do is bring together the ecosystem across North America, North American industry, academia, government, and coordinate on a plan to address 6G. And so today we have about 82 members in Next Alliance and about 600 people. I put a list of the members in the next couple slides, just in different categories. And you can see that the companies that are contributing, you'll notice that many of these companies have a good global presence. So of course we have an inherent global viewpoint, but the mission is to make sure that the needs of North American are addressed in the global 6G vision. So that was the full members. On this slide is a category of contributing members, which includes members that can be part of any of the working groups that we have in the Alliance. And you'll notice a lot of the university members are listed here as well. And finally, we have a group of government members, which is a new class of membership, which opened just a few months ago. So this group is still growing, but is a very important group to the mission that we have in Next Alliance. Okay, so let's just talk about the Next Alliance North 6G vision. And we refer to this as a foundational vision because it will evolve and grow as our work continues. The report that we just released has nearly 50 pages of information that defines our vision in the form of really 3 main components that you see listed here. The first is a set of 6 audacious goals. Then we have a roadmap that considers every stage of the life cycle and the stakeholders along the way. And finally, we outline a set of 6G leadership research priorities that are developed across our key working areas, like the applications working areas, societal needs, economic goals, and government actions and technology development. Okay, so I mentioned we have 6 6G audacious goals, and each of these were selected by the membership as the top North American priorities and ambitions. And looking at the figure to the right, we list these 6 goals. And I'll go through each of these in the upcoming slides, but I do want to call attention to the figure on the left with the tiers. Each of the tiers represents a different level of stakeholders that need to be aligned in order to maximize the synergies. So we build the goal descriptions with this 3-tier structure. So for each of the goals that we have defined, we looked at what are the national imperatives, and this has the government and business stakeholders in mind. We looked at the applications and markets. This is intended to to look at the users of 6G and the new vertical markets. And of course, the technology development is included as part of the goals and the vision as well. And this is where the key innovation is done, and it's really the nuts and bolts of what will make 6G work. So I'll go through each of the goals just really quickly in the interest of time. Trust, security, and resilience was the first goal that we quickly defined by the membership. And not a week goes by where we don't hear about another hacker or ransomware incident. And post-pandemic, we're transitioning to an even greater remote working, greater amount of remote working and learning than we ever had before when we originally designed 5G. So the 6G system has to be trusted, safe, and reliable in all circumstances. So for each of the audacious goals, I've provided examples of national imperatives and research challenges, and I've listed this on the slides. This has been provided by the membership as part of the input, and And this describes the what, why, and how associated with each goal. And there's more examples in the report, but in the interest of time here, I'm just going to say a few words about each of these goals, and I won't have time to go through some of the details on each of these slides. So the second audacious goal is for 6G is to enable a digital world experience. And what we mean by this is, multi-dimensional, multi-party, multi-sensory experiences that really go beyond just sight and sound, and will bring life-improving use cases and create new economic value. There's a quote I have from a philosopher named David Chalmers at New York University, and he has a saying that virtual reality is genuine reality, so let's embrace it. In other words, AR, VR, and XR experiences are going to become the norm of everyday life. And if you think about it, that's really should be no surprise, since communication advancement has time and time again been driven by better ways to enable remote experiences that mimic physical experiences. Okay, cost efficiency is the third goal, which spells out all aspects of the 6G architecture. Looking at devices, wireless access, core network, cell site backhaul, as well as the energy efficiency of all of these. And all this must be done in order to provide more cost affordable solutions. And this must be done uniformly to promote digital equity across the urban, rural, and suburban regions. Affordable access to wireless services has really become essential to American lives as well as the lives globally. And I think there's still a long ways to go here. In the United States, for instance, less than 24% of the US population has access to 1 gigabit per second service, really due to the availability of that infrastructure. Okay, the fourth goal is about digital or distributed cloud and communication systems. And this is a goal to better unify the cloud and communication systems so that we have greater scalability across all components of the network. And of course, jointly designing compute and communications will better address the needs of the low latency mission critical systems and be a platform for new service innovation. The one example I can think of here where North America may be unique from other countries and have some urgent priorities here is in the automotive industry, where North America has more personal use of automobiles in our commutes than any other region in the world. And as we move closer to self-driving cars, low latency mission critical services are essential. So so that collision avoidance decisions can be processed in a distributed cloud as opposed to the distant cloud. So that might be something that we prioritize highly in North America. AI native means that we want to build 6G with artificial intelligence included into the major components of the design. And we do this right from the beginning rather than an afterthought, like we're seeing with today's 5G advanced updates. And the targeted goal here is to build 6G AI natively, which will increase the robustness and performance and efficiencies. Okay, and finally, the last of the 6 goals is sustainability. Global climate change and the need to reduce our carbon footprints is critical for 6G, and considers really the most energy efficient technologies need to be considered. But the vision goes beyond energy efficiency. We're looking at a broader set of objectives such as researching better ways to extract raw materials, helping consumers become more environmentally responsible in their decisions, and looking at recycling of materials that would otherwise get thrown into landfills. The example I like to give here is if you look at scalability of IoT, that cannot happen unless we solve the sustainability problems. If you have devices that have 10 years battery lives and we want to scale to 1 trillion IoT devices, that would mean that we'd be replacing 300 million batteries every day. And so that's not sustainable. And so we need more energy efficiency solutions. Okay, so that covers the 6 audacious goals that we have currently in Next G Alliance. And, and that's a major component of the 6G vision, but the 6G vision we have also includes the roadmap. And the title of this presentation is Roadmap Overview, and roadmaps have paths and destinations. So that's the point of having the visual here. The life cycle shown here is NextG Alliance's order for the various stages that we'll see over the next decade, going from research, which is the key focus area today. There's a lot happening on research. And then we move to development and manufacturing. And here we mean, starting to build the prototypes and technology demonstrations, then moving to the standardization, market readiness, and realization phase. So, more specifically, there are the desired outcomes of North American leadership. So first, we're looking to get a more powerful work collaboration across our industry, academia, and government. And this is something that has to be improved in North America relative to how we did this in 5G. We're looking to build a robust marketplace that uses innovation and new applications. And finally, we want increased ownership of the technology advancements, for instance, in securing domestic production capabilities. And on the right-hand side, the key question always comes up is what's going to be distinct or different about the 6G compared to 5G. So some examples that that are in our report and I pulled out for the slide is the multi-dimensional, multi-party, and multi-sensory experiences. We want to design for AI native, trusted, and ethical AI. There's a lot of interest in higher frequencies for using higher data rates in the terahertz and sub-terahertz regions, as well as the dual use of spectrum for communications and sensing. We saw some of that in Mikko's presentation as well. And 6G will be designed for sustainability in mind and consider the new technologies such as zero energy devices. And finally, quality of life and work experiences will be transformed. Okay, so this slide summarizes the ideas from the various working groups across NextG Alliance. And there's white papers and reports which will be released later in this year from NextG Alliance, which will give further details. We already have a Green G report, which is also available on our website, which looks at some of the sustainability issues, and that was published last January. And the back half of the roadmap report currently has some high-level view of the information that you see here. But these are the working groups that we have in NextG Alliance, and for the interest of time, I won't go through these and just move to my last slide, which is where do we go next on our roadmap work. So, working with the government early in the life cycles is critical, and we're going to be looking to continue to increase building our relationships and increasing the government membership. The second point, research initiatives need to move towards developing requirements and KPIs. So that's an activity we have ongoing now. We'll continue being part of the global consensus building by bringing our contributions to the ITU-R vision for 2030 and beyond, and continuing to have more discussions and webinars like we're having here today. And finally, from the perspective of road mapping, it's really about facilitating innovation and collaboration, both domestically and internationally. So we'll keep working this roadmap, and I look forward to continuing collaboration towards 6G. Okay, thank you.
All right, thank you very much, Doug, for the comprehensive presentation. We already had 3 questions on the Q&A room, and thank you, David. You have taken care of answering all 3 of them. That's great. The audience is a little bit shy in putting their questions so far. So I've already prepared, obviously, a few questions to the esteemed panelists. I'm going to kick off, and for the audience, anyone, please feel free to put your questions in the Q&A room. So I will start with you, David. As you presented, actually, ETSI has been quite successful into bringing tangible contributions to 5G, be it through NFV, MEC, MWT, you name it, all these ISGs. So the question to you is actually, how do you see ETSI repeating or even boosting that success in 6G, specifically through what new technologies and what new engagement models?
Yeah, it's a good question. In 5G, I would say the companies came to us. So ETSI can make standards for pre-standards and full standards. We have very good relationship with 3GPP because as ATIS, we're a founding member. What we'd like to change this time is that we would like to go to the research project. So we're already reaching out to Empower. We're going to be having discussions with HEXA-X. We're working with the SNS joint undertaking. We're working with 6GIA. We're working with Networld Europe. All of these European entities, very interesting. They have research roadmaps. They have priorities. The European Commission has put in funding. So what we're doing is actually trying to learn from where they're pointing research and the biggest issues which need to be advanced through research. So one could be energy efficiency, a very difficult thing to resolve. And then as soon as we see projects coming out of Horizon Europe or others, even national projects in the UK, in France, in Germany, we would talk to them and say, okay, we can help you accelerate that into the 4 standards in 3GPP and then onto market. For now, I mean, it's hard to say. We don't, I mean, there's some very good presentations from HEXA-X and very good presentations from ATIS as well. We don't fully know where 5G will stop and where 6G will end. We have a number, 2030. We have a 3GPP release around release 20. But we don't know exactly what will be inside. Millimeter wave will continue to expand. Sub-terahertz will be developed. Energy efficiency exists already in 5G. So, you know, really identifying the technology. People have asked me this week, what is the technology? And it's quite easy to say terahertz. But there's so many other technologies as well, which is why we're really listening to what the industry is saying, talking to our partners, and then really sharing standards roadmaps, research roadmaps, and visions. So we all kind of know where everybody's going, which is why I'm really pleased to be on this event today. Thank you.
Fantastic. Thank you very much, David. So in the meantime, we got 2 questions on the Q&A. So I will give these a priority. So the first question from Hongwei Zhang, it reads, with telecom softwarization, there is emergence of interest in or exploration of generation less wireless evolution. What is the panel's take on this thread of exploration? What are the implications to expected research, innovation, and standardization efforts? Perhaps Mikko or Doug or David, would you like to take it?
I
Also with helping in answering the question. So where is the question now? So
in the Q&A, if you open the Q&A next to the participant list.
Yes, I was looking at the chat and didn't see it there. So
next
yes,
to the chat.
Good. Yes, I see it now. Yeah. So yeah, let me take still a look at that. If my colleagues would like to start answering, please feel free.
Yeah, maybe Doug, would you like to take it?
Sure, I'll just maybe say a few words about this. You know, I think with every generation, we've moved a little closer to more use of software in being able to implement the cellular solutions. I think that will continue as we go into 6G. It also means that with each generation we're moving into more of a situation where we can do more incremental updates as we go forward. So I mean, as David was mentioning, I think you know, we're not quite sure about what's going to define 6G and what's going to be 5G, and we're always going to be borrowing something from previous generations, but there'll always be something new that, you know, some new feature that will be very distinct and definitive for 6G. So but I think softwarization will continue to see this grow, particularly on the infrastructure side, like we're seeing with O-RAN Alliance. So we'll definitely see more and more of this as we go forward.
Excellent. Yeah, thank you very much, Doug. Mikko, would you like to add anything to this, or would you like me to give you the next question?
Yeah, I think that the essential things were pretty much already raised, and the generations have traditionally been linked to the radio part. The kind of overall significance of the radio with respect to like the changes to be expected, so in proportion is going down, and then there are these trends of other parts where the kind of move from one generation to next is reduced.
Yeah, that's perfect. So please don't go away, Mikko. So I think the next question is going to be to you, and I think David as well. So it's from Prit Rusipu. How big influence will you see on smart surfaces and smart environments on 6G?
So they are an interesting new technical opportunity. So of course, also in the past, there has been ways of receiving and retransmitting in a more active way. So there has been approaches in that front, but then this would be like a mixture of active and passive. But mostly passive, and certainly it gives more opportunities. So in its own area, affecting how the propagation takes place, certainly has an effect that needs to be strongly taken into account. So in that respect, certainly something to pay attention to.
Yeah, that's perfect. Yeah, thank you, Mikko. So David, especially that you highlighted this ETSI RIS ISG as being one of the ISGs, first ISGs in ETSI. On the specific topic of smart surfaces, would you like to give your perspective on the question?
Yeah, certainly. It's a very interesting technology. It's I wouldn't say it's simple. It's not simple, but it's a way of reducing the energy budget of operator networks in built-up areas, because it's not fully active. It's more passive, and you can actually increase the line of sight. You can see around objects. You can with massive MIMO and holographic radio. In addition, you can bring these elements in. You can get much better coverage in built-up areas inside buildings as well. So it's going to help with the very difficult energy efficiency sustainability element, in addition to other things as well. So it's an interesting one. Then it can work over multiple frequencies, and you bring that in with terahertz as well. So you can combine the technologies. I think those are going to be two very interesting technologies. Let's say for beyond 5G, maybe we won't have to wait for 6G. Maybe we can get some RISs out there installed. There's already many companies and research universities. They have products, they're testing them, they're doing line of sight, they're doing reconfigurable real-time tracking. So there are solutions out there. It could actually come in before 6G.
Yeah.
Very interesting.
Fantastic. Yeah, thank you very much, David. So we only have 2 minutes left, and I'm still, I have a question that's very close to my heart. And that's actually one of the reasons why we bring this, all the esteemed panelists together here today. So if you take actually ETSI, if you take HEXA-X or the 6GIA in Europe, and now ATIS NGA, I mean, there is a lot of similarity, shared agenda, shared scope, shared, if you like, objectives or targets, if you like. So how can we get all these key organizations to partner together and work together and complement each other and push really a joint transatlantic, vision, roadmap, specifications for 6G. So anyone would like to start with this?
So if I immediately jump into it, one track is of course greatly contributed by you for creating this kind of events, and also from HEXA-X side and the other colleagues here, they have been mentioning about interactions. So with HEXA-X, we have been organizing as well some events in the near past, and plan to continue this. So we need to maintain a good amount of interaction and exchange of information. So that's the first main key thing.
Okay, brilliant. Yeah, thank you, Mikko. Doug?
Yeah, so I mean, I would agree with Mikko that I think information exchange needs to continue. And again, I thank you for inviting me and the Next Gen Alliance to this webinar, because it's exactly the type of engagements that we need to be doing at this time. I do want to comment that in the very short term, one of the priorities that we have for Next Gen Alliance is to build the North American collaboration and to increase our government engagements. Right? I mentioned that our government, North American governments have only been part of Next Gen Alliance for the last few months. So there is a domestic priority that we need to address, but of course this international consensus building is very important as well. And neither side can afford to have any divergence here when we're aiming for a global standard. So practically, I think we should continue to participate in workshops and panels and be very proactive for this information exchange. And then mid to long term, maybe there'll be more formal collaboration opportunities, which I think will personally be very valuable.
Oh, that's fantastic. Yeah, thank you, Doug. And David, comes to you.
Yeah, I mean, I always believe these sort of events are perfect. In ETSI, we participate to lots of 6G symposiums and 5G events, and with a project funded by the European Commission called Indico, we've done presentations to North America, China, Japan, South Korea, and so we're always saying what we're doing and asking what they're doing. Very important that we do this repeatedly, but also actually looking at each other's documents. So we've considered documents from Japan, from North America in building our roadmap. So that was done once, but keeping that synchronized and harmonized as we move forward. So, new developments, very important. So it's not a one-time job is what I'm saying. And honestly, make sure that all of this early work, which needs to be exchanged now, it ends up in a single standards body, which hopefully will be 3GPP, and we don't see the non-desired fragmentation of standardization, because if we have a global system, we need a single global standard. So that's something I'm very protective of as well. So.
That's fantastic. Yeah, thank you very much, David. Please allow me to thank all the three esteemed panelists. Thank you very much for making the time today, for sharing your perspectives. It has been a great pleasure to be with you today. Thank you to the audience. And now I will turn it over to you, Serge, for the final remarks.
Yes, let's close on this very positive statement about international cooperation, which is, of course, of utmost importance for us all. Thank you, Alain, for bringing this very nice panel. Thanks to the panelists. And as you know, we will meet you again, hopefully in 2 weeks from now, with a quite different topic, but equally important. It's about education, building capacity, and we need to educate, of course, and develop skills for all those talented young people who will build 6G and certainly beyond 6G. And we have a program that is going to be chaired by Matt, who is one of the organizers of the networking channel. And we will have two panelists, two famous panelists who have been contributed to research and education for years. Jim Kurosi, who is the co-author of certainly the most widely distributed textbook on networking, and Larry Peterson from ONF and University of Arizona, who started to publish an open source book. And it will be very interesting to listen to the conversation about how education and developing skills and the material for that purpose will evolve in the future. So we'll meet you hopefully in 2 weeks from now. And in the meantime, take good care of you. Thanks a lot for joining the channel. Bye-bye.
Thank you.